Hello everyone, I am Manoj. Today I am going to talk about the topic neutron radiography and computer tomography. Definition of neutron radiography. Neutron radiography is the process by which film is exposed by first passing neutrons through an object to produce a visible image of the materials that make up the object, and it is primarily used in scientific investigations. Neutron imaging. Neutron imaging is the process of making an image with neutrons. The resulting image is based on the neutron attenuation properties of the imaged object, and these attenuation properties distinguish neutron and X-ray images. Attenuation of X-rays is proportional to density or denser materials stop more X-rays, whereas neutrons absorption is not. Some light materials such as boron strongly absorb neutrons, while many commonly used metals allow most neutrons to pass through them. Neutron radiography process. Neutron imaging requires a source of neutrons, a collimator to shape the emitted neutrons into a fairly unidirectional beam, an object to be imaged, and some method of recording the image. Moderation. After, after neutrons are produced, they need to be slowed down to the speed desired for imaging. This can be achieved with water, polyethylene, or graphite to produce thermal neutrons. In the moderator, the neutrons collide with the atomic nuclei and slow down. Eventually, the speed of these neutrons will achieve some distributions based on the temperature of the moderator. Collimation. In the moderator, neutrons travel in many different directions, whereas they should be collimated to produce a good image. To accomplish this, an aperture will allow neutrons to pass through it, surrounded by neutron absorbing materials. Limits the neutrons entering the collimator. Object. The object is placed on the neutron beam as close as possible to the image recording device. Then conversion. Neutrons are difficult to measure directly and need to be converted into some other form of radiation. Some form of conversion screen generally is unemployed to perform this task. Though some image capture methods incorporate conversion materials directly into the image recorder. Often this takes the form of a thin layer of a gadolinium, a very strong absorber of thermal neutrons. Image recording. A variety of methods are commonly employed to produce images with neutrons. Until recently, neutron imaging was generally recorded on X-ray film, but a variety of digital methods are now available. Neutron radiography. The term neutron radiography is often misapplied to all neutrons imaging methods. Neutron radiography is the process of producing a neutron image that is recorded on film. This is generally the highest resolution form of neutron imaging, though digital methods with ideal setups are recently achieving comparable results. The most frequently used approach uses a gadolinium conversion screen to convert neutrons into high energy electrons, which expose a single immersion X-ray film. The direct method is performed with a film present in the beamline, so neutrons are absorbed by the conversion screen, which promptly emits some form of radiation exposing the film. The indirect method does not have a film directly in the beamline. The conversion screen absorbs neutrons, but some delay exists prior to the release of radiation. Neutrons. In some rare cases, radiography is done with neutrons. This type of radiography is called neutron radiography or neutron imaging. Neutron radiography provides different images than X-rays because neutrons can pass with ease through lead and steel but are stopped by plastics, water, and oils. Neutron sources include radioactive sources, electrically driven DT reactions in vacuum tubes, and conventional critical nuclear reactors. It might be possible to use a neutron amplifier to increase the neutron flux. And then we move to computer tomography. Introduction of computer tomography. Computer tomography is a well accepted imaging modality for evaluation of the entire body. CT scan machines uses X-rays, a powerful form of electromagnetic radiations. The images are obtained directly in the axial plane of varying tissue thickness with the help of a computer. Some pathology can be seen in sagittal or coronal plane by reconstruction of the images by computer. CT has undergone several evolutions and nowadays multi-detector CT scanners have been evolved with have better application in clinical field. Comparison of CT with conventional radiography. Conventional radiography suffers from the collapsing of 3D structures onto a 2D image. CT gives accurate diagnostic information about the distribution of structures inside the body. Advantages computer tomography over conventional radiography. To overcome superimposition of structures, to improve contrast of the image, to measure small differences in tissue contrast. And let we see the tomography process or diagram. In this, the light rays are passed to the human body. Mm, It's like a tube movement. A principle of computer tomography. The internal structure of the object can be reconstructed from multiple projections of the object. Mathematically, principle of CT was first developed in 1970 by Radon. Proved that, and he proved that an image of unknown object could be produced if one had several number of projections through the object. Let me say about the various parameters of computer tomography. Uh, Number one, slice, matrix, pixel, voxel, CT number, windowing, window width, window level, and pitch. Then we move to slice or cut. The cross-section portion of body which is scanned for production of CT images is called slice. The slice has width and therefore volume. The width is determined by width of the X-ray beam. You can see the images, and this is called slide or cut tomography. And then we move to matrix. The CT image is represented as the matrix of the number. The two-dimensional array of numbers arranged in rows and columns is called matrix. Each number represents the value of the image at that location. This is the diagram of matrix. CT number. The numbers in the image matrix is called CT number. Each pixel has a number which represents the X-ray attenuation in the corresponding voxel of the object. You see that says this matrix is specified with some columns and rows. In that column, we can see some numbers, and this numbers, and this numbers is called a CT number. And then we move to steps of CT image formation. First, when the object will inside the CT scan, first it will scan the data. Then the image can be reconstructed to digital image, and the digital image can be moved to digital analog conversion, and the scan will represent in our screen. These are the steps to CT image formation. Phase of CT scanning. Scanning the patient or data acquisition. X-ray generator, X-ray tube, X-ray filtration system, detector system. Reconstruction. Simple black projection, iterative method, analytical method. Thank you. And I conclude these topics. Thank you for